All right, hello everyone. We're live. We're doing it live, baby. It's Tuesday night. We have a lot of solar activity right now. Wow. I mean, we forecasted this. People that watch the channel, they're like, we're not surprised. But still, it's always epic when you see these sort of explosions on the sun. These are huge explosions on the sun right now. We have this sunspot group right here, which is actively growing larger. It was already hyperactive on the far side, launching out coronal mass ejections, or basically just big waves or blobs of plasma out towards Venus and also interstellar object 3I Atlas. You may have heard of that. Very, very interesting. It launched a bunch of solar storms that way. Now it is active again with a 1.8 X-class flare. Boom shakalaka. That is the biggest solar flare that we have had since June 19th. And that was a 1.9 X-class flare. That was also what's called an impulsive solar flare. So it's just a very quick jolt of energy, but no big long duration event that pushes out a coronal mass ejection. This one did. This, in fact, launched a coronal mass ejection directly to Comet A6 Lemon, which is performing its perihelion on November 8th. We were talking about that in the last video, about how this comet is getting closer and closer to the sun in alignment with this sunspot group, which is actively developing at this moment in time. We've been seeing activity. It is likely that we're going to see something like this, and well, we did. But the latest development is that we just had a 1.1 X-class flare literally moments before I went live just now. So this is the absolute latest imagery here. This is our 131 angstrom view of the sun as provided by the Solar Dynamics Observatory. So we get right here, this big guy, 4274, and then this one at the end. Let's see if I can pause it right at the end there, launching a very fast coronal mass ejection with a 1.1 X-class flare. Here we have our SUVI imagery, and this shows us our latest 1.1 X-class flare right there from the limb. Now, keep in mind that this is still slightly behind the limb of the sun. So the eastern limb, its solar coordinate system. So this is the east side of the sun. This is the west side of the sun. This is slightly behind that, meaning that a lot of that light energy actually got blocked by the sun itself that's still in front of that region. So this is likely a stronger flare than this one, because this looks really high velocity. I mean, it's just really, really, really rapid. And it's happening right now. We are in this right now. So the point of today's video, what we're going to discuss today is the risk that technology has as it relates to the sun, because this sort of activity is not necessarily uncommon to solar maximum. We have had activity like this before in this solar maximum cycle, which is solar cycle 25. Specifically last year in May and October, we had a lot of activity like this. But this is quite unique because if you add what's happening just today, these two X-class flares back to back, you add that to the far side activity over the past 2 weeks from these sunspot groups, this then becomes one of the most significant and active periods that we've ever observed on the sun. So certainly right up there in that top category. We don't know the size of the solar flares that are occurring on the far side, but they were big because we can look at our coronagraph imagery to get a sense of this, but we can't actually measure the X-ray flux. But we know that they were big. But now they're rotating Earth facing. Well, Earth at 1 astronomical unit is actually very close to the sun. Like once you start learning a little bit about the solar system, and also you go a little bit further beyond other star systems and everything, like Earth is pretty close in. Neptune's at 30 astronomical units. If you have a space station floating around Neptune, if a coronal mass ejection sweeps by, you're not going to have to worry about, oh my God, like the technology is going to maybe short circuit or something, because you're at 30 AU. That coronal mass ejection really spread out by the time it got to Neptune. Or Uranus at 20 AU, Saturn at 10, even Jupiter at 5. Going from 1 to 5, inverse square law, big difference in terms of how much that expands out. We're at 1 astronomical unit, folks. Even just having a base on Mars, or let's say a civilization on Mars, would be much better from that perspective because it's at 1.5 AU or so. So at 1 astronomical unit, we're really close in. And if you look at the big picture, you really zoom out, okay? Technology is a new thing. Well, I mean, maybe it's not. But in the history context that we know, technology, transistors, all this stuff, this is all new. And so we've created a whole bunch of conductive circuits on the planet. There's natural conductive circuits, geologically and more. There's also a bunch of bioelectric circuits in our body. So therefore we also interact with these energies in a very real way. Some people are more sensitive. Some people are more aware and conscious of these things. Other people are just a little bit less clued in. That's fine. But we've also created a whole bunch of technological circuits and effectively just created little conductive pathways. Semiconductors, they can conduct, they cannot conduct, right? Well, what happens when you get a huge influx of energy from the sun? The big source of energy in our solar system, 99.86% of the mass. It can cause short circuits and technological disruptions and problems and geomagnetically induced currents and power grid outages. It can cause satellites to fail due to increased drag, even from dielectric charging deep down in their actual circuitry that causes them to short circuit and fail. You can get a ton of technological problems. Some solar storms are even so strong that if they were to hit, and some of them have, like the Carrington event, and there's other bigger ones too, super flares, if they hit the Earth, that impact is so powerful, it creates an electromagnetic pulse. So just a huge pulse of electromagnetic energy that then energizes anything that it comes in contact with. Massive swing in the electric and the magnetic field, which can cause technology to fail. So in the grand experiment that we're playing with, right, life, humans, technology, now hoping to maybe become interplanetary species, right, we got a fairly limited time window because the sun is very active, and until we're like spread out, like the sun could, if it so chose, it could launch something or many things out towards the Earth to knock technology out. This is not some out there conspiracy theory or something. It is literally just physics. And most people aren't aware of it or give it any proper kind of thought individually or at the societal scale because it simply hasn't happened in our modern technological age. Back in 1859, we had what's known as the Carrington event, which was a very big, fast, powerful solar storm impact, but we had telegraph wires at that point. And so we have some reports on that and telegraph stations catching on fire, and then some people even be able to communicate without their batteries, and some lines melting. We have 1872, 1921. These are other examples that are kind of similar, but we don't have, an iPhone in the pocket or these massive AI data centers or anything else. Like all the infrastructure that runs the internet now, all the telecommunication satellite swarms, all the telecommunication infrastructure down on the Earth, the power grids that support all this. We didn't have any of that back in 1921, 1872, 1859. Before that, before it would have just been purely geologic and geophysical effects, in addition to biophysical effects, how a solar storm impact would affect us. Add into that the fact that Earth has a strong magnetic field, which is actually what helps this EMP effect to occur. I'll explain the difference later. That means that it's like, okay, why are we so close to the sun? Is that good for technology in the long run? Like, we may just be kind of like in a Goldilocks time zone right now. Not actual distance from the sun, but a Goldilocks time zone where we've just been lucky that nothing's happened. So that's what we're going to talk about today. We've had two big X-class flares today, as we have been forecasting on the channel. In fact, going back to July, I forecasted that we would see an increase in, a heightened probability. This is what a forecast is. I forecasted that we would likely see increased solar activity due to the superior conjunction and perihelion of 3I Atlas. Everyone else is talking about aliens and they're talking about all this other stuff. We're focused on like the real stuff here. So back in July, we're saying, hey, when 3I Atlas gets close to the sun, and it specifically makes that Earth-Sun Atlas alignment, and then perihelion is 8 days later on the 29th of October, probably going to see some heightened solar activity because there's a bit of a track record and history to this with comets and other things. Guess what? That's what we saw from the sunspot groups. Now they are rotating Earth facing. And in fact, today, right now, this one here, which exploded earlier, launched it out right towards Comet C 2025 A611. Let's put that one back on. Here we see this first X-class flare, 1.8, launch a big coronal mass ejection out into space. We'll check that out next. But this is a long duration flare. These are really now working together sympathetically as they have been already. So they're keeping it up, but this sunspot group has been growing, and it looks like we do have some sort of impact from that already here on Earth. So this is not even close to Earth center direct, which is right here. If it launched from right there, ooh, man, okay, like we got some solar storm coming in, some geomagnetic storming coming. But it launched from pretty far off to the eastern limb. Even then, the shock wave is going to hit us. That is what the latest NASA model is showing. We're going to go down everything, and then we'll do a Q&A in this video. So hello and welcome, everyone. I'm your host, Stefan Burns, geophysicist, geologist, space weather guy, cosmic bro, whatever you want. I'm your dude, here to talk about what is happening energetically here on Earth. So we examine all these different things and bring them together, because if you don't go multidisciplinary, you're not going to get the entire picture, and everything works together holistically. So we look at geologic events and things like volcanic eruptions and earthquakes, geophysical energy changes, also sometimes weather events like big weather patterns, hurricanes, cyclones, and more. Solar activity, space weather, how that connects to all that. All these terrestrial dealings are influenced by the sun. You just turn, if you have the light switch of God, you can turn the sun off and play around with like the different solar systems, and you just like turn our sun off, everything changes on Earth. It gets cold, dark, and the geology in many ways grinds to a halt, totally changes. So of course it's the number one factor. It is certainly very causal. Then we also expand out, look at comets and interstellar objects and cosmic forces and more. So if you like the sound of that, then please subscribe to the channel. I keep you up to date with what is happening, when it's relevant, what's impactful, and it's videos nearly every single day. So that is my thing. And when big things happen like this, I'm live. It's not 36 hours or 48 hours later where I finally come on, you know, like, hey guys, you know, we had something happen 2 days ago. It's like, no, we're live now, folks. We're catching this one as it's happening right now. So let's look at our chronograph view. And this is our C3 chronograph. We'll probably have to look at our CCOR chronograph as well to capture that latest X flare on the chronograph. But here we see one earlier on. So we've had a lot of activity. It's not just these two X flares. There's also been big flares before that. That was a big coronal mass ejection. There's our 1.8 X-class flare launching a coronal mass ejection out into space like that. We'll watch this a few times. And what we're looking at here is effectively the solar wind and any plasma and solar storms that launch from the sun. They put this disk over it, so it's denoted by this circle there. That's the diameter of the sun. They just, you know, denote it that way. 32 solar radii across, so pretty wide viewing window. Here we see all the stars in the background, and we're tracking the sun. So they appear to move like this, but in reality, we're moving and rotating around the sun. We see that big solar storm launch out, basically a big blob of plasma. That's the best way to describe it, honestly. Wave, blob, there's different things. There's very complex physics involved with plasma, complex dusty plasma, and sometimes you actually get more by simplifying it down to, hey, big blob of plasma flying out, rather than all these names that no one understands, coronal mass ejection. And yeah, it's an ejection of plasma from the solar corona, which is the outermost atmosphere of the sun, but it's really just a whole bunch of energy and plasma launching out from the sun. That's the coronal mass ejection. That's the solar storm. A solar flare is the explosion on the sun, and those light photons take about 8.3 minutes to reach Earth. It's very, very quick. We can measure a solar flare with the X-ray flux. So here we have our 6-hour view, but let's go to our 3-day view, all right? It looks like we're actually ramping back up again right now. If we go back to that 6-hour, looks like we're ramping back up. We're still in M-class territory right now at this moment. R1 radio flare, we'll look at that too. We're now experiencing radio blackouts. So the technological effects are already happening. You don't need to wait for the solar storm. You can simply have these big pulses of light energy come in from the sun, you know, every 8 minutes when there's a flare, boom, 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 to cause some pretty significant disruptions. So we see that things have been ramping up. We had some M-class flares yesterday. We had one today. That's that first one that we saw in that chronograph and also in the 131 angstrom imagery. Here's our 1.8 X-class flare. There's our new flare right now. It's happening. If you go outside and maybe you're on the west coast, you're Hawaii, right? You look up at the sun, you are seeing the sun flaring. Now you're not actually going to see it like in detail because it's very bright and everything, but you can be looking at this in real time if you want. Don't look at the sun for too long. Don't burn your eyes out. But eclipse glasses or a solar telescope, there are ways to do this. Look how we've been ramping up though for a week now as these sunspots have come into view. So it's been quite significant. And let's actually, before we go look at some of our other stuff, let's just look at these sunspots. I mean, this one that's behind me there, that one is growing and getting gnarly. It's really starting to look gnarly. So it's very compact. Sometimes these sunspots can be a lot bigger. This one is very compact. This one in the middle there, not as big, though it does have a lot of brightening around it here, as you can see. And then this other one, we don't even see it yet in the Earth-facing intensitygram because it's still behind the limb. So that tells you that's a 1.1 X-class flare. That's actually probably the bigger explosion today. But this sunspot group right here, 4274, is looking pretty significant, pretty big. So that is going to take about 5 days to get here, and we have a few things happening right now. We have the full supermoon tomorrow. It's actually, I think, in about 24 hours. Go out tonight if it's dark and look at the moon, especially when it's rising, and boom, it's going to be big. The biggest supermoon of the year, closest in its orbit to the Earth. We also have the Tauri meteor stream that's peaking around this time right now. A lot of people already catching fireballs in the sky as a result of all these little Taurids coming in. Go look at the constellation of Taurus and you may catch one of these things, a little zip across the sky, different colors. And we also, of course, have these solar flares. We've had this unusual kind of earthquake swarm off the coast of Kamchatka, Russia, which is where we've had the most seismic energy released thus far for 2025. Due to all the activity there this year, the magnitude 8.8 megaquake, multiple magnitude 7s, tons of magnitude 6s and 5s, seems that's ramping back up again. There's also a big coronal hole on the Earth-facing side of the sun right here that's going to connect to Earth soon with its magnetic field, triggering a coronal hole high-speed stream impact and probably some geomagnetic activity, probably a G1, G2 storm from that. So all these things are active. There's a lot of different ways that they connect together. And really, if you look at it, like we are often very lucky and the sun does not launch these mega solar storms our way. But if we had to examine this very realistically, the weak link in this whole thing is technology, right? Like we can go outside and ground ourselves and do fairly well with a big solar storm impact. And I'm pretty sure the fish are going to keep swimming. The butterflies will keep flying here on Earth. But technology is quite delicate in that sense. So you could get some sort of Terminator robot made out of metal and you wouldn't want to shin kick that thing, but you get a solar flare pop off. I'm going to do a lot better than the Terminator robot. Let's just say that. So we have this. This is a real risk factor that exists on our planet that most people are unaware of that could really shake things up pretty quickly. And here's our D-region absorption map so we can see these solar flares and their impacts on the planet. We see this first one come in. This is the 1.8 X-class flare. I was actually out on a walk when this was happening, so I got that good energy coming in. Really peaked over South America. Should be right about here. There it is. There's that 1.8 X-class flare. Boom! Right over the Americas. And then we can zoom this model along a little further. It should be up to date with this latest one. There it is right there. So that's our latest 1.1 X-class flare right there. And so that hit the Pacific very nicely, Hawaii and more right in that time window. But now as we see with our X-ray flux, it is going back up again. So let's refresh this. We're doing it live, right? We're doing it live. It's still elevated, showing that this is a pretty significant solar storm, because when these sort of explosions on the sun are long duration, they have a more likely chance of ejecting a lot of plasma in a big solar storm. It's the impulsive ones that go up and right back down that typically don't result in anything. This, though, is looking like a long duration one. This one was long duration, had this, I think that was barely an M-class flare or a high C-class flare. High C-class flare as well, kind of stacked on top of it. This other one going off, a lot's happening. So here we can look at our geomagnetic storm impact scale, because you can have solar storms launch off and not hit Earth, right? And that doesn't mean they're not affecting the solar system as a whole energetically, but you really need a hit to Earth for that to trigger this whole maybe technological meltdown, which we don't want. At least it'd be societal chaos. So it's not the first thing on my list. You know, I'm not hoping to punch that on the bingo card. Let's just say that. Some people are. You know, and maybe it'd be good for us in the long run, but I'm not, it'd be total societal chaos. So not on my list of things I want. G1 storm, this is minor. We get these all the time. This is from like a minor solar storm impact, maybe a coronal hole high-speed stream. You may get some weak power grid fluctuations. Satellites maybe get a bit more drag. Unlikely for this to really cause any problems. Migratory animals, they'll be effective if they're way up in the Arctic circles, Antarctic circles, the high latitude regions, right? Aurora will be common up in those areas. If you're up in Alaska, you're probably going to see aurora if you have good conditions for it instead at the right time. G2 storm, moderate. Now we're starting to talk. G2, G3 storm, this zone right there, we get them less frequently, but pretty frequently overall, especially during solar maximum. You're not really going to get these much during solar minimum, basically at all. Really not at all. So G2, G3, nothing to just like cross off and be like, it's nothing. Like, these can be strong storms with real impacts. We've seen a lot of power grid issues with weak power grid systems, specifically like Cuba, Puerto Rico. I'm not afraid to list them off. Some people shy away from it. No, Cuba, Puerto Rico have really weak power grids, understandably so. Getting whacked with these hurricanes and cyclones. Haiti also, these are the ones I know of. They're fairly low in latitude, but still, even G2, G3 storms at times over the past few years has caused there to be power grid problems there. Perfectly lined up in time. Also, there's been tech outages that have lined up with this. You know, a variety of websites going down, Amazon Web Service problems, things like that. Sometimes will line up exactly. Or like, oh, Verizon doesn't work for 50 million Americans for 2 hours. And it'll be right during a G3 storm. And they'll say it's due to some other thing. But it's like, guys, it was right at the peak of the G3 storm. So probably was related to that. So these aren't anything to scoff at. And you can see, like, this is directly from NOAA here. They address that this is all possible, right? Transformer damage is possible with a long duration one. You know, you may actually have to do corrective action with your spacecraft because of the increased drag. Radio problems can exist. So there's a lot there. Now, here is where we're really talking. And there's even a category basically beyond this. But here's where things really get exciting with G4 and G5 storms. So a G4 storm is a severe geomagnetic storm. We get these not that frequently, but during solar maximum, probably a few times a year, if maybe 2 to 3 times a year. G5 storms are quite rare. They are very notable. It's not likely you're going to get more than maybe one a year during solar maximum, though you could get more than one. Last year, we had a long duration G5 storm, the Gannon storm. This is May 10th to the 12th. You also call it the Mother's Day storm. That was, last year, so about a year and a half ago. We also had a G5 minus storm back in October, around the 10th to the 12th of October. And the minus means that it was just slightly weaker than a G5. So it was a G4 plus, G5 minus. It was like right in this zone. The Gannon storm, the Mother's Day storm, firmly a G5 storm. We did not, thankfully, have any sort of big power issues or technological disruptions from any of this stuff that's happened in this solar cycle or from solar cycle 24 or solar cycle 23, which goes back to the early 2000s. You have to go all the way back to solar cycle 22 to 1989 when Quebec had a power outage across the entire city when there was a big solar storm impact. But again, we haven't had like a Carrington class solar storm impact really since 1972, and that one had a magnetic field configuration that was not Carrington class. It was positive polarity, so it just basically deflected around the Earth. And even then, it triggered sea mines to explode in Vietnam, in the ocean. They just put them out. They were fully operational and good, and then they're caused by magnetic detonation, and the big EMP pulse came in, and boom, these sea mines started exploding in the Vietnam Ocean. So then you have to go back to 1921 to get a really strong effect, 1872, and then 1859. And you go back even further to Miyake events, which we really don't know what they're from, whether they're solar, cosmic, maybe like Earth itself, we don't know. Just a huge increase in energy on the planet that we observe via radioisotopes. Those are 10 to 100 to even 1,000 times stronger than a Carrington event. And we get them fairly regularly in the historic record. So it's not like they're once every 10,000 years. It's more like, oh, we get a clustering of them every few thousand years. So they're not happening every year, every decade. It's more like every few centuries, but wow, they do happen. So this technological experiment that we are playing with societally is very much in the baby stage. It may seem very complex and awesome right now and beyond belief, and it is, but it's still very much in the baby stage. And you know, we could very well have the sun decide to just take it out if it wanted to. Question is, does the sun want to? I don't know. Does the sun want robots flying around the solar system? I don't know. So these are very real effects. If you read them, possible widespread voltage control problems on the power grid, high frequency radio could be sporadic satellite navigation, degraded for hours, low frequency radio navigation issues, blackouts or complete collapse of power grids is possible with a G5 extreme geomagnetic storm. Navigation systems may be out for hours or days. And again, I mentioned that category beyond this, there isn't one officially. This caps at G5, but there's a big difference between what happened in May and what happened with the Carrington impact and what happened with the Miyake event. So we could probably characterize a Carrington event as like even like a G6 or 7. And then a Miyake event would be like, I don't know, G10 or something. Like this is just imaginary numbers now, but they are so many orders of magnitude stronger than, for example, what happened last May, that this categorization basically, it doesn't matter at that point. Now, here's why this is a real risk, and especially kind of like right now, like we can't ignore this. Look at this activity that's been happening on the far side in this wave of coronal mass ejections. So this is a top-down model. It's a space weather model. We have the sun right here. Here's the Earth. Here's some very space probes and stuff, okay? But look at how we've had this wave sweep across and that these sunspots are still very, very active. They have not let up. So we see some of the old ones there. Basically, we're about to get hit with that solar flare machine gun. And it's just about to hit us now. Has not done so yet. We have already some maybe flank impacts coming in. We do have that coronal hole high-speed stream. We've had that for a while. That's connected to some very powerful earthquakes. We'll talk about that later. But we have not yet had this solar flare machine gun hit us, and it is still very, very active. We have here, what did I want to show you next after this? There's a lot of things to discuss today. I want to show you the NASA model for this. So here we have the NASA shock model for this 1.8 X-class flare. Now, it's unlikely that the coronal mass ejection from what just occurred, the 1.1 X-class flare, it's unlikely for that to hit us because it's from behind the limb. It'd have to be a really exceptional explosion for it to somehow like move around the sun and hit us. But that 1.8 X-class flare firmly on the Earth-facing side, though still at a bit of an angle. But here we have the shock model. So they model it for the bulk and for the shock wave of this. The shock wave is going to be faster, it's going to be wider, stronger, but the bulk is most of the plasma. This is just showing the shock wave. Shock wave does hit us with this first run model by NASA. The bulk model that they have shows it going more like this. So let me pull that up for you. We can look at our latest models here. And this is all provided by NASA. They're shut down right now. Like they're basically shut down, though there are some groups that are still working. So it's not a complete shutdown. They're probably working without pay, but what's the chance that we have this incredibly active sunspot trio? There's 3 sunspot clusters, a trio of sunspots that are rotating Earth facing, that's already created one of the biggest periods of solar activity if we look at it from a solar system scale in decades when our own incompetence in the United States has us shut down. And that impacts the world because the systems that NASA and the US government has are relied on by organizations and people and groups all over the world. So we have the European Space Agency, we have the Chinese Space Agency and other groups, but the space weather reporting tools and all that, it's top of the line for the United States, NASA, NOAA, etc. And this government shutdown certainly isn't helping. Doesn't mean that everyone's furloughed and not working, but a lot of them are, and it's certainly not helping. So how silly is it that this is happening right now? It's really just shows our collective stupidity. And we all have to take responsibility for that, unfortunately. If you're not American, I absolve you of that, okay? Though every government right now is just like this. I mean, it's crazy. So here we see our space weather activity. We see our solar flare right there, 1.8x flare, 1.1. They'll probably model this out, but it's going to take some time, a few hours. But we can go over here and click on this to get our analysis. And we have two of them right now. I already showed you the shock feature. Here's the bulk. So let's watch this one right here. And we can click it. Here we see the bulk of that coronal mass ejection. And so we see that it's not interacting with the Earth. This is the top-down view of the ecliptic plane. So it's going like this. So this is just the first run model. We'll wait on NASA, or NOAA. We'll also wait on the UK Met Office. There's a whole bunch of groups that take this data from the coronagraphs, which I showed you, and process it into space weather models. This is usually the fastest though, which is why I'm showing you this right now. This is the bulk. It does show it missing, but you see this high plasma density feature right there. That's called a co-rotating interaction region. Behind that, we have a high-speed stream that is going to sweep by the Earth very, very soon. So let's look at our latest coronagraph imagery, or 195 angstrom imagery to see this coronal hole. And here it is. We'll turn this on. And here is our favorite coronal hole on the sun because it has been alive for quite a while now and it's transequatorial, meaning that its high-speed stream will sweep by the Earth, effectively guaranteed. Whereas if it's down here, up there, it's probably going to go above or below, something like that. This one being aligned on the equator is basically shooting that high-speed stream of solar wind out exactly towards Earth. It's fairly large. It's a negative polarity, meaning it connects nicely to Earth's magnetic field. And we've been seeing high magnitude earthquakes in time, in this resonance with this coronal hole here. So when it goes geoeffective, we're going to have enhanced geomagnetic storming. That's going to be in about 3 days or so. I'd say probably around, today's the 4th, probably around the 7th, we're going to have this be firmly connected to us and maybe a G1, G2 storm. We're also expecting some potential flank impacts around that time. So just in general, starting in a day or two, expect geomagnetic activity to go up and stay up. We're probably going to be in a long duration, on and off, geomagnetic storm here on Earth for the next 7-10 days or so. Like if you live in a place that could get aurora or somewhere that there are dark skies nearby, you may want to plan out some aurora viewing. I may do that myself too. But when this goes geoeffective, it hits us first with this high density plasma region at the front of it, and then the fast solar wind follows up behind it. The solar wind density drops, and by that time it's usually rotated to the limb, and that's when we've had recently these high magnitude earthquakes 4 times in a row now for about 4 months or so. So boom, 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 and we just had this big earthquake sequence off the coast of Kamchatka, and it does not look like a normal earthquake and then aftershock sequence. It looks like a preliminary swarm for something much larger. And that is the area of greatest seismic release for 2025, and it's probably not done yet. And this is the coronal hole that's really well connected to that area and its earthquake. So correlation, causation, whatever, is it certainly connected temporally in time almost perfectly. That's undeniable. Whether you want to talk about correlation, causation, and do that whole thing, that's up to you. Okay, so here we have our 3D view of the solar system. And I'm showing you this because, as we talked about in the last video, the the comet C2025 A6 Lemon is perfectly in line with that sunspot in the northern hemisphere, which has been very active. So this is set for today. So we see the Earth right there. Here's the sun. There's our comet. Remember, it's above the ecliptic plane. So you can see that A6 Lemon here is above the plane. It's going down like this. Let me go forward a few days. Here's the perihelion of A6 Lemon. Its closest approach to the sun is right there. And then it's going to zoom off like this. Came from below the plane, way back here, went above. Then it's going to cut back below it. It's perihelion right there on the 8th of November. Today's the 4th, but if I set it up like so, and we kind of just rotate this a little bit, here we have the Earth, here's the sun, there's Mercury and A6 Lemon. Oh, look at that. We get a nice planetary alignment with the closest planet to the sun, right in alignment with that sunspot group, right in alignment with comet C2025 A6 Lemon. And Mercury is along the ecliptic plane eventually, but A6 Lemon is above. And so we get both these sunspot groups firing off at the same time. We can actually see, oh, look, actually Mercury is below the ecliptic plane. So you have Mercury below the ecliptic plane where we just had that 1.1 X-class flare from that southern hemisphere sunspot group. And then you have A6 Lemon to the north of the ecliptic plane where you had the first 1.8 X-class flare blast off from the most active group and the one that's further along on the Earth-facing side. So just again, I just showed you this, okay? Look at this. Here is that sunspot group perfectly in line with that, right? It doesn't take the genius to figure it out. Here's that other sunspot group lined up perfectly effectively with Mercury. Now this one is still actually a little bit further behind the limb, but it is aligned in that below the ecliptic plane vector, and it's rotating towards Mercury. And today we have the alignment with the two. So some planetary geometry that seems to be connected to what's happening today. And I think that in general, this is just very, very active. We had a 3i Atlas here trigger a lot of the solar activity. That's at least what I have been talking about and what I think. But certainly the temporal connection is undeniable. How we had all the solar storms launch off right when this went with its superior conjunction of the alignment Sun, Earth, Sun, 3i Atlas. Now we have this happening here. And I think it's likely, because the sunspot group is growing, the one that we can see, it's growing. It's been growing a lot today. I think it's likely that this continues through Earth facing. And it's not going to fizzle out right here. It's possible. Certainly a probability. But I would say the most likely outcome is that we continue to get a lot of activity towards Earth in the days ahead. And I explained that in quite a good detail in the last video. Here we have an article which I was skimming through, which discusses the catastrophic effects of an EMP attack or a severe solar storm. And let's just kind of scroll through this a little bit and read some of the takeaways here, because a lot of people just don't know the history. They don't know the details of this, and it's good to know, and it's a very real possibility. So here's interesting, right from the get-go, a little bit of history. In 1962, deep in a Cold War with the Soviet Union, the United States conducted Starfish Prime, a nuclear weapon test over a remote region of the Pacific Ocean. And they actually did this up in the ionosphere. It's one of the few nuclear tests that we did well above the Earth, and it actually triggered geophysical changes across the planet. Like, that's some fascinating research to read into if you want. So, Starfish Prime, the test was successful with one unexpected result. 800 miles away, streetlights burned out, TV sets and radios failed, and power lines fused in parts of Hawaii. 3 similar Soviet tests that same year over Kazakhstan caused more serious infrastructure problems long before the far more vulnerable and ubiquitous microchips that power today's world. So that's one example in 1962, or actually multiple in 1962. We talked about the Carrington event in 1859, Quebec in 1989. There are these things. A nuclear test, like a nuclear explosion, creates an electromagnetic pulse. A solar storm impact does too, okay? And actually can be much bigger. Solar storm impact can be a lot bigger than a lot of nuclear warheads that exist and hopefully we never use. what a mistake it was to blast all those things, to create them in the first place. But, you know, detonating thousands of nukes on the planet back in the 40s, 50s, 60s, 70s, 80s, 90s, yeah, that doesn't have an effect on the planet. That's the biggest psyop that exists right now. Like, all these other things, right? But the fact that no one talks about the nuclear test, the thousands of nuclear tests that we did, and then no one connects it to what's happening on our planet energetically, climate change and all the odd things and earthquakes and more. Like the biggest earthquakes that we've recorded on record were 1960 and 1964, right? All these nuclear tests are happening right around that time, and no one talks about that. I'm like the one person that's like, hey guys, you know, probably detonating all those thousands of nuclear bombs affected our planet in some pretty significant ways. It's going to take maybe thousands of years to like remediate. Yeah, no one talks about that. It's crazy. It's absolutely crazy. But they'll talk about what's happening, you know, in the magazines and stuff, and with Taylor Swift. So it goes into a lot of things here. Let me find some of the other. What is an EMP? Let's talk about this. An EMP. An EMP strike destroys critical infrastructures with two different effects. An EMP pulse can hit both critical hardware components and the systems that control and use them. And these two effects combined have a devastating impact. So this is specifically kind of talking about it from the nuclear angle, but you have this magnetic pulse wave that travels from either a nuclear explosion or a solar storm impact that's of sufficient size. And the magnetic field is very, very strong. And it's this big jerk, basically, where it's like really powerful and then it swings to the other side and you just get this huge change in the magnetic field. Every magnetic field induces an electric field if there's a change in the magnetic field. If you have a static magnetic field, you have a static electric field associated with that. If you have a change in the magnetic field, like a wave, then you're going to create an electric current, because it gets induced. The electric field alters and causes these charge carriers to start sloshing around, and electrons are the first ones to do it because they're very low mass, 1,800 times less mass than a proton. So what can happen is anything that's conductive gets hit by this wave of the magnetic field, which travels through everything effectively, unless you have super heavy shielding, like lead shielding will absorb that EMP blast, and the lead will be conductive, but everything, and experience a whole bunch of electric currents, but everything, let's say in this Faraday lead shielded box, will be unscathed by that magnetic field. It won't have passed through it in any significant level. If not, then this magnetic field sweeps through everything, and let's say your computer or whatever, you know, I can't pick my computer up and show you. Well, I guess I could. You know, your computer has all these little conductive circuits in it. If that magnetic wave sweeps through it, it could cause short circuits, and then the technology fails, because you only need a couple failures for it to just completely go offline. Cars are electric nowadays. A lot of power grids are run with very little direct kind of monitoring. There's a lot of automated systems. So you get a big surge sweeping across from that solar storm impact over a long duration, like we're talking 2, 3, 4 days, we really just wouldn't be able to keep it up. That's a very real risk. The world's electric grids are also threatened by natural events that could have similar devastating consequences. Recent research by the National Academy of Sciences has concluded that unusually severe solar flares and their associated coronal mass ejections have occurred about once per century at a level that could burn out electric infrastructures worldwide. And our electric infrastructure could be protected from EMPs and severe solar flares and CMEs for estimated costs that appear low enough to have no significant effect on electricity costs or rates. You know that they would raise those rates on you though. But that hasn't been done. So we have not done that. As far as I know, we haven't done that. And at least in the United States, our grid is pretty old. There's a lot of good people working on this, but like at the top, these people are so greedy. It's disgusting. So yeah, this is like a very real risk. Here we could talk a little bit more. In February 2009, the National Academy of Sciences completed a NASA-funded study looking at the risk of an EMP-like crisis caused by a severe geomagnetic storm, or even like extreme or beyond, like we talked about, right? The study concluded that solar activity could cause severe, potentially nationwide damage to the electric grid, and that should be expected about once in 100 years. The last two such events took place in 1859 and 1921. Oh, wait, 104 years ago. That was exactly 104 years ago. We got lucky in 1972. Talked about that one briefly. We had basically a Carrington impact, but the magnetic field wasn't conducive. So we got really lucky. I call that the lucky storm. With multiple days of severe solar weather bringing auroras all the way down to the equator in those years, 1859, 1921, shutting down telegraph networks all around the world. Imagine what would happen today. You just put New York without power for 6 hours and imagine what would happen. Imagine for 3 weeks. Oh my God. So they concluded a severe geomagnetic storm could damage or destroy enough of several hundred key U.S. transformers to shut down vast regions of America's power grids. And when would this happen? Would it happen during the spring and the fall when the weather's fairly nice? Maybe. Would it happen during the dead of winter or maybe the peak of summer? Possible. You go down south, Mississippi or Florida, there's times where it gets so hot and humid that it's above the wet bulb temperature. If you don't have air conditioning and you are outside, you can't drink to hydrate because it's 100% humidity and your sweating is not going to cool you off and it's above your body temperature and you can literally just burn out. This is a very real risk now due to global warming. And then we're having bigger swings also in the opposite direction. Huge amounts of snowfall that are being recorded at times. It's really sudden blizzard conditions, huge cyclones and hurricanes. It's really getting crazy. So yeah, these are all very real things. They all connect together. It's all connected together. If you haven't figured that out yet, well, it's time to look at this from a holistic perspective. Let us discuss the final piece of this puzzle. Earth is at 1 AU. NASA shut down. We hope that actually doesn't affect anything, but Earth is at 1 astronomical unit. Earth also has a very strong magnetic field, all right? So this is the other key component. If you don't have a magnetic field, you actually have a lot less risk of things of this nature. You have other risk factors, but it's the magnetic field swing that induces these electric currents. If you don't have the magnetic field, you get the solar plasma that comes straight in. You have what's known as a ground level enhancement. You just have tons of energy coming into the planet, tons of energy coming into the planet and just effectively increasing the electrostatic field. So just the electric field in general gets really strong. That could affect technology, sure. But if you just create a strong electrostatic field, you're not really generating to the same degree these currents. Whereas with the magnetic field, now you get this sloshing in the magnetic field, and therefore you get these really powerful electric currents to form. So Earth has a powerful magnetic field. It's quite strong. So if it was weaker, the chance of a big EMP-like effect in some aspects is actually reduced. Again, it's kind of apples and oranges. But Earth's field is quite strong, very strong. So that increases the chance. It also protects us from a lot. It protects us from the solar wind and high energy particles from space. So we're happy to have the magnetic field. But the flip side is that if you do get a big solar storm impact, you're going to get big swings in the magnetic field, which technology simply is not designed for. Consumer technology or any of these things. AI data centers, whatever it is, it's simply not designed for massive fluctuations in the magnetic field, 5,000 nanotesla in strength, something like that. We don't know what would happen in that case. So yeah, the magnetic field has weakened as it relates to 1,000 years ago and also 3,000 years ago. It was stronger back 1,000 years ago, 3,000 years ago, but it is quite strong in the geologic context. So if you want to learn more about that, I have a complete video guide on Earth's magnetic field. It's a whole playlist, and then also there's specific multi-hour long lectures on Earth's magnetic field and more in that playlist. So I'll link that in the video description once the live stream is done, because a lot of people are uneducated about this. And it's good to know the history and the geology of Earth's magnetic field. It's good to know the physics of it so we have a better understanding of what this actually is. And and how it's changing across time. And it is quite dynamic and active and alive. So I believe that is basically it for today's video. Before we do our question and answer, just wanted to give you a update. And that is that we have a restock on our electricity on earthevolution.com. This is my website where I sell holistic wellness products, also our merchandise. If you want to get, for example, the Boom Shakalaka shirt, I almost wore that today because of the X flares, then this is the place to do it. We have the Boom Shakalaka shirt in pink and in banana. So this is watermelon. That's the back of the shirt, by the way. This is the banana. That's the front of the shirt. So size small to 4XL. This is the original merch that we have for the channel. We also have the Interstellar Atlas shirt right here. Interstellar 3i Atlas with artwork from my father, Lee Burns, on the back. And this is size small to 2XL, all fulfilled by a third party, so it ships out pretty quick. This is the Cosmos Within t-shirt. Has sacred geometry built in with the Fibonacci spiral over the solar plexus. I love this shirt. More artwork by my father, Lee Burns, on the back, the cosmic pyramids. Really great energy to this shirt. Comes in white and also midnight blue. So that's available size small to 4XL. But we just mixed up a whole big batch of electricity, which is right here. And so this stuff is awesome. In the last website tour I did, I talked about the herb coffee, which is great. And so you can pick this up too if you want. It smells so good right now. But the electricity is also really, really similar, but herbal, whereas the herb coffee is more coffee based. This makes a great iced tea. And what this is good for is cognition and focus and productivity and optimizing your neural pathways and more because of the different herbal ingredients it has. So it has yerba mate for caffeine, has ginkgo for neuroprotection and neurooptimization. Then it also has lemongrass, orange peel, and peppermint. Lemongrass is really good for your digestive system, as is peppermint, and orange peel is good for flavor. I mean, all these herbs are good for you, just in general. But this is not only good for your brain because of the ginkgo and the yerba mate, but it also works really well for your digestive system and therefore optimizes that microbiome gut-brain axis, because most of your neurotransmitters are produced in your gut by bacteria, which then are transmitted through the vagus nerve, and also autonomic nervous system signals are transmitted by your microbiome and whatever else is there through the vagus nerve up here, influencing your behavior, your thought process, whether you have brain fog or not, etc. So optimizing the microbiome gut-brain axis is really key. This does it all in one go, whereas coffee is a little limited in that regard. And that's why the herb coffee is great, because this also has herbs that help you optimize that microbiome gut-brain axis, whereas regular coffee kind of falls short on that. And this has lion's mane, which is, again, another neuropromoter. So both of these are available on the website. They're both really good, but a lot of people haven't tried the electricity, and it's really excellent, and it's cheaper. You'll notice that it's cheaper price. Really great iced tea, super tasty because of that peppermint, lemongrass, and the orange peel. So check that out. Merch on the website, as well as you saw earlier, as well as many other tea blends. We are fully in stock except for the spirituality, which is out of stock. So I will work to get that back in stock as soon as I can. Thank you for your patience on that. So without further ado, let us load up our latest SUVI imagery so we can get a real-time view of what's happening with the sun as we do our question and answer. And we'll just refresh this here, and then we'll go through a few questions before I sign off for the night. And I hope you're all doing well. I hope you've been enjoying the live stream. We covered a lot today. If you stuck with all of it, you hopefully learned a lot, or if you already knew this, it was a refresher for you. That's kind of the whole point of my channel, is to really be education first. I think it's really, really important to always learn new things and more. And so that's what we do here on the channel. So it looks like we had a little flare right there just recently. Yeah, so another flare right there that just popped off. Very interesting. So let us start our question and answer. Okay, we'll start with CC here. Question, there was just a Dragon launch or a space launch. I saw it going over my farmhouse in Pennsylvania, had the spinning tail of light. I don't know, but if someone in the chat could look that up, that'd be great. It'd probably be easier for someone in chat to look that up because there's a whole bunch of them. So is someone aware of a recent SpaceX Dragon launch? Please type that in, help CC out. Thank you for the super thanks. And what is the update with 3i Atlas? No real update right now. I mean, there's people still talking about it, but in terms of like brand new update right now, something crazy, there's nothing really there. So I will let you know once there's like some new, really significant new imagery, or maybe that NASA data from the HiRISE orbiter, you know, the Mars Reconnaissance Orbiter HiRISE camera. If that gets released, I'll update you. Some sort of big orbital shift, anything like that. You know, once new imagery starts to come in, I'll definitely be updating you. But at this moment in time, basically my last update still stands. So yeah, that's the latest on that. And I'm in Puerto Rico. That means no electricity. Well, your power grid's weak. So sorry. Doesn't mean it's going to go down with these solar storm impacts. It's a heightened likelihood though. So you probably are already aware of this and have backup supplies and everything. Or at least I hope you do, and I wish you the best. God bless. Okay, this is an interesting one. Hello from Naples, Italy. Wonderful place. I haven't been there for 8 years now, but I hope to be back soon. You guys got Campi Flegrei right there, right nearby. Many flights got canceled all over the European Union. Shall we expect a technological reset or a satellite falling show? Oh, there we go. Campi Flegrei showing signs of an eruption too. Yeah, well, a satellite falling show would be a pretty big solar storm impact or impacts. So that would be pretty intense. If we just get another G5 storm like last May, you're not going to get a satellite falling show. There will be more, there will be problems and there will be satellites that fail, but like a satellite falling show, I imagine like the whole sky alight with thousands of satellites. You'd probably need something like a Miyake event for that. So I don't think that's going to happen at any point soon. It's possible though, but the sunspot like this one is going to have to really become much more significant for that to be the case. It's not there yet. This one, we don't know what it looks like. That was a pretty, I mean, look at that guy. Watch, wow, what a beautiful solar flare and coronal mass ejection. So like maybe this one's quite large. We don't know. Or a complete technological reset. We're exploring these possibilities. It's always a possibility, but it's not a high likelihood in the grand scheme. But we're seeing this sort of solar activity, and we know that Carrington events are possible. We know that Miyake events are possible. So that's why I'm talking about it, because we are seeing this activity at some of the highest levels in a long time. So yeah. Florial 8 is saying or asking, do you think there will be an EMP soon? If so, what are the three main things that have in place besides food and water? Food, water, a garden. That would be key. And then in terms of like a solar storm EMP, what you would just want effectively is to have a ton of tinfoil so you can wrap up your electronics. Like just take a cardboard box and wrap that with like heavy aluminum foil and then put your laptop and phone in there. So when that solar storm comes in, I'm talking like Carrington level. If a Carrington impact came in, that's what I would do, is I would take a cardboard box and I would take as much electrons as I could. We also have a solar panel set up here. And it's 800 watts. It's nothing big, but we have 800 watts with a 1 kilowatt hour battery. I would take that and I would also put it in that box for when that was to occur. The solar panels would probably be fine. Just disconnect the wires, things like that. Like you could get through this. It's the big data centers that probably have some issues. I mean, they're well grounded and everything, but I think consumer electronics are probably actually going to be mostly fine if you take those steps for something like a Carrington event or bigger. Has 3i Atlas made a move towards Jupiter? Not that we know of. I mean, it's getting close to Jupiter, but in terms of directing itself to go exactly to Jupiter, not that I know of. I'll keep you up to date if we find out that's the case. And do X-flares affect the South Atlantic anomaly more or cause the South Atlantic anomaly to expand? It's not really the same time scale, but certainly a big pulse of radiation coming in, hitting the Earth. You know, you're going to get more of that radiation in the South Atlantic anomaly. But in terms of it affecting the South Atlantic anomaly directly, not really. And And wondering if that UPS plane crash that just happened was due to a solar cause. I don't know. I haven't heard about that. So maybe, possibly, probably not, but hard to say. So that is it. Thank you all for joining in today. I've been your host, Stefan Burns. This is what we do on the channel. We cover everything that's happening energetically here on Earth nearly day by day. I do my best to keep everyone up to date with breaking updates, but I also just don't bombard you with stuff that you don't need to know. So if it's a quiet day, I'm not going to be online. I'm going to be doing research and other things, enjoying my life. And I encourage you to do the same. Very powerful energies active right now, going through the middle of November and even into late November. So this entire month is looking quite dynamic. So I suggest that you subscribe. If you found this video enjoyable, subscribe to the channel. I'll keep you up to date, teach you along the way. Links to all the different resources in the video description so you can check them out. And I'll be back with more. So thank you again. Wishing each and every single one of you well. Please take care of yourselves. Make sure you do some earthing and grounding. And I'll see you all in the next video. Thanks so much.